Okay, what we're looking at today is integration and finding a particular solution, which I kind of showed this a little bit the other day because you needed a bigger picture, so now we're kind of breaking it back down into parts. So we're still going to use our rules for integration, but remember when we integrate indefinitely, we always have that plus c, so we're going to look at today how to find a particular solution, or in easy words, finding c. Find a particular, that kind of ran together, sorry, solution. It's our learning target. So let's say I give you this differential equation, dy over dx equals 3 square root of x dx. And at the point 4, 1, I want to find a particular solution. And in class we're going to look at something called a slope field, which I think kind of makes these really cool. This differential equation right here has its own little slope field. It kind of looks like electromagnetic type fields. And I'll show you some pictures of those, and there's something that we develop them and look at them more in Calc 2. But for right now, we're just going to talk about how to find a particular solution. So let's start by rewriting this as dy equals, oops, I already had the dx here. Cross this out and pretend I know what I'm doing. All right, pretend that's not there. dy over dx equals 3 square root of x. Okay, so the first thing we would do is write 3 square root of x times dx. So we'd solve for y. And then we talked about how we integrate each side. And I told you yesterday in the video that when I do that, this side just gives me y. That's that rule. dy would just give me y. This side, I can move my 3 out front. So I have 3 times the integral of x to the 1/2 dx. Now you got to use your power rule. So add 1. So I get 3 times, that would be x to the 3/2 if I added 1, and then I have to divide by the power. Well, the power is 3/2. Okay, which equals, let's simplify that more. You get 3 here. If I divide by 3/2, it's the same as multiplying by 2 over 3 x to the 3/2. These would cancel, so I get 2x to the 3/2 plus c. That's my general solution. Now, it was at the point 4, 1. So that was our point. So I'm going to plug 1 in here for y and 4 in for x, and I'm going to find c. So 1 equals 2 times negative 15 is what c equals. So c equals negative 15. So my particular solution is 2x to the 3/2 minus 15. That's how you do that. Okay? So what we do, we can do lots of things with that. One thing that we look at is, what if I say this? Instead of writing dy dx, what if I say the derivative of x equals 4x squared, and I know that the function evaluated at 0 equals 2. Can you find a particular solution? Or can you basically find the original function? I want to find the original. So if I want to do that, I have to integrate this side. So if I integrate that side, I get 4 times the integral of x squared dx, which is 4. Power rule, add 1. So you're going to have x to the 3rd divide by the power over 3 plus c. So that's almost my original function, but I need to know what c is. So I know my original function equals 4x cubed all over 3 plus c. To find c, I have to use this other piece of information that they gave me, which was when x equaled 0, my function equaled 2. So 2 equals 4 times 0 cubed over 3 plus c, which c equals 2. So my original function, my original f of x, if I know the derivative and I know a point, I can find my original function is 4x cubed over 3 plus 2. That's my original function. Okay? So, one really, really cool thing that you can do, and I love problems like this because it makes you think about your derivatives and integrals, so you can expect to see these. Let's say I say this: your second derivative of x equals 5. Your first derivative of x evaluated at 2 equals 3. Your function evaluated at 0 equals 7. And all I want is just the original f of x. What does f of x equal? That's what I want. So I'm going to go up here to the starting. Right here, if I take the integral, or if I integrate my second derivative, that would give me my first derivative. So I'm going to integrate my second derivative, and when I integrate my second derivative, I get my first derivative. So let's do that. So I'm going to integrate 5. It'd be 5 dx. And if I integrate 5 dx, that gives me 5x plus c. Well, I need to find c. That's where this comes in. I know that my first derivative is equal to 5x plus c, and I know that when x is 2, my first derivative equals 3, so 3 equals 10 plus c, so c equals negative 7. So now I know that my first derivative equals 5x minus 7. Well, that's great, because now if I know my first derivative, I can find my second derivative. I can find my original function. I'm sorry. I want to find my original function, and to find my original function, if I know my first derivative, I integrate my first derivative. Okay? And when I do this, I can break this up into 2. This one gives me 5x squared over 2 minus 7x plus c. So this is my original f of x, but I still need to find c. What did they give me that will help me find c? All right, so now I forgot what I was saying, but let's put, to find c. We have to use this information to find c over here. Lots of arrows and lines. It's nice. So we know that f of x equals 5x squared over 2 minus 7x plus c. And I know that when x is 0, the function equals 7. So 7 equals, this is going to give me 0 plus c. So c would equal 7. So the answer to that question, what is my original function? F of x equals 5x squared over 2 minus 7x plus 7. Okay? And we're actually going to use stuff like that today and tomorrow. We can do that with acceleration and velocity and position function all over again. So, see you in class.